3 heavy space vehicles are being developed by the National Aeronautics and Space Administration under the project name Saturn. This film report, number 16, will cover progress on the Saturn I and IB during the period April through June 1963. A significant highlight of this report period was the checkout of Pad B facilities, Launch Complex 37 at Cape Canaveral, using the SAD-5 booster, the S4 Dynamics facility stage, and ground support equipment. Wet tests at Canaveral are designed to check out Complex 37 equipment involved in propellant loading operations. Actual propellants are used in the tests. Simulated manual loading methods are checked first. Then the entire loading sequence is performed automatically. Some difficulties were encountered during first phase testing, requiring additional components. Tests were resumed and successfully completed late in June. Following wet tests, inspection revealed 2 welts on the hydrogen side of the common bulkhead of the S4 Dynamics facility stage. However, the bulkhead showed no signs of leakage during the liquid hydrogen loading tests, and the stage is acceptable for stratification tests scheduled next quarter at Marshall. Also at the Atlantic Missile Range, work on Saturn launch sites is progressing satisfactorily. Construction of Launch Complex 34's liquid hydrogen facility is on schedule, with completion expected late next quarter. The design work on Pad A Complex 37 to support Saturn IB is on schedule. The Saturn I instrument unit electrical support equipment for Pad B Complex 37 arrived at the Cape in late May. Meanwhile, at Marshall, the booster for the 5th Saturn I flight vehicle, SA-5, entered post-static checkout. Discrepancies were discovered, particularly in the propulsion system. Rework was necessary. Following completion of rework, electrical systems checkout started in mid-May. The booster will be shipped for arrival at the Cape about 2 weeks before S-45 stage arrival. Located at Marshall's Quality Division is a Saturn Instrument Unit Motion Simulator used for attitude calibration of the stabilizer and control system of the SA-5 instrument unit. Positioning capabilities are in 3 axes, with displacement accuracy of 1% of displacement angle. Positioning the unit for attitude calibrations and simulated flight position leaves all components in their respective flight configurations, eliminating loading effects from long cables and extraneous noise pickup. The control system has automation capabilities that can be computer controlled, permitting complete automated calibration and checkout of control systems. The booster for the 6th flight vehicle, SA-6, underwent 2 successful static test firings at Marshall's Test Division, the first for 35 seconds and the second for a period of 142 seconds. Post-test inspection revealed minor discrepancies, such as small fuel leaks and a torn GOX diffuser screen. Corrective action has been taken. The SA-6 booster, second in the Block 2 series, is now undergoing post-static checkout at Marshall's Quality Division. Assembly of the booster for the 7th Saturn flight test vehicle, SA-7, was completed this quarter, and the stage is now undergoing pre-static test checkout. Structural fabrication of the spider beam for the 9th Saturn flight vehicle, SA-9, is complete. Assembly operations on the tail section and clustering of tanks is underway. The Fairchild Stratos Corporation of Hagerstown, Maryland is now underway in the fabrication of various components related to the micrometeoroid measurement device which will fly aboard SA-9 and SA-8. Manufacturing of the wing panels for the mock-up is on schedule. Testing wing panel capacitors is accomplished by using a vacuum bell jar. Electronic components are subjected to rigid testing prior to acceptance. Micromodules are inspected through the use of powerful magnifying equipment. Chrysler Corporation, production contractor for Saturn I and IB boosters at Marshall's Michoud operations in New Orleans, completed clustering of all propellant containers for the booster for the 8th flight vehicle SA-8 during this quarter. Delivery has been made of all H-1 engines for the stage. Also, fabrication of the barrel assembly and thrust and fin outriggers for the 10th flight vehicle SA-10 is complete. Fabrication of the spider beam and thrust structure is underway. At Marshall's Michoud operations, construction work this quarter included the building of an electronic fabrication and checkout facility and the installation of air conditioning systems in various offices and laboratories. All construction work is being done under the direction of Michoud's support services contractor, the Mason Rust Company. Dynamic testing of the S4 stage instrument unit with both the Jupiter nose cone and the boilerplate Apollo spacecraft began at Marshall's Test Division early this quarter and was completed in late June. The SA-D5 booster at the Cape for Complex 37 facilities checkout was removed from Pad B in late June and will be returned to Marshall during the next quarter for additional dynamic testing. A new clean facility was placed in operation this quarter in Marshall's Manufacturing Engineering Division. The clean area is subjected to a higher internal air pressure in order to minimize the possibility of contaminants entering the room from external sources. Saturn vehicle parts to be clean are disassembled and passed through a drying oven, then washed in an electronic cleaning vat. Filtering equipment removes contaminants down to the 10 micron or less level. A final check of the part is made by using a microscope. After completion of the cleaning process, all parts are hermetically sealed, then sent to the user. The RL-10 engine hydraulic actuator simulator for the S4 stage was tested this quarter at Marshall. For test purposes, an engine is not used, but is simulated by the mass's pendulum. Two hydraulic actuators, mounted 90 degrees to each other, represent either the vehicle's pitch or yaw axis. The hydraulic actuator system reacts to the angle commanded by the vehicle's guidance system, allowing for attitude control in the pitch and yaw planes, stabilization, and reduction of vehicle bending. Test analysis will help determine if the flight control circuits and mechanical power converters are adequate to satisfy vehicle requirements for flight. At Pratt & Whitney's Florida Research and Development Center at West Palm Beach, S4 stage RL-10 engines are thoroughly inspected prior to acceptance. Each engine is inspected visually, then taken into a booth for a black light inspection. Using an ultraviolet lamp, all pump inlets and valves are examined carefully for defects. Utmost precautions are always taken with all parts associated with the RL-10's cryogenic propellants. After its final acceptance test, each RL-10 engine is weighed with all equipment attached. The vehicle manufacturer must know the engine's center of gravity, since this is a factor which can strongly affect the vehicle's guidance system. At Marshall's Test Division, construction work was completed this quarter on a prototype sound suppression stand, which uses an H-1 engine for testing. The 165,000-pound thrust engine is fired into the suppressor tank. Results of the firings will provide data related to the basic acoustical scaling laws. The sound suppression facility will itself be a model for much larger power plant suppression systems. Acoustic measurements are made during tests to check the effectiveness of the sound suppressor. At Rocketdyne's Canoga Park facility, stainless steel furnace-brazed thrust chambers for H-1 engines are being developed to provide longer test life and more consistent manufacture of units. The first unit has successfully completed 2,300 seconds of main stage engine test, and the overall braze operation is considered successful. Another development at Rocketdyne was the testing of three types of injectors: the low differential pressure fuel LOX injector, the modified cooling posts, and the low differential pressure fuel injector. The modified wagon wheel injector exhibited high-frequency instability characteristics. On May 4th, the S-4 battleship test program was completed at Douglas's Sacramento test operations, with a final LOX depletion firing of 444 seconds. A total of 5,440 seconds of engine firings was accomplished. At the conclusion of the firing program, gimbal tests were run on the battleship vehicle to provide needed dynamic data on the engine actuation system. The battleship tank was then stripped of accessories. 5 of the engines and the tank were shipped to Marshall. The tank will be used for slosh tests, and the engines will be used on the S-4 dynamic stage for further gimbaling tests. On April 1st at Sackdoll, the initial all-systems vehicle propellant loading test was aborted when a fill nozzle leak caused damage to the test stand. Corrective action was taken, and the second test begun on April 9th. About 1 minute after storage pressure increase, observers noted tank canning in a vertical plane. Canning partially smoothed out after several seconds. Following necessary internal insulation repair, tanking procedures were modified and tests resumed. Problems encountered during detanking indicated leaks in the common bulkhead. The vehicle was removed from the stand in mid-May for bulkhead weld and insulation patching. Additional tanking operations on Test Stand 1 will begin early next quarter. On April 16th, the S-45 flight vehicle was moved from Douglas's Santa Monica plant to the docks at San Pedro. The stage was transported aboard a barge to begin its water journey to the Sacramento test facility. The stage arrived at its destination 5 days later and was checked out in the Engineering and Development Building prior to being installed in Test Stand 2B. The S-45 was installed in Test Stand 2B, and pre-static checkout began in late June. A full-duration hot firing is scheduled for next quarter. At Santa Monica, Douglas successfully bulge-formed an aluminum sheet yielding 2 segments for the S-4B stage's bulkhead dome. Bulge die techniques may be used to augment segment production on the stretch press. Overall construction on the S-4B facilities at Huntington Beach is continuing. During this quarter, the fabrication and assembly building was completed and tooling installation was begun. Chicago Bridge and Iron Company, subcontractor for Douglas, shipped sections of the battleship tank to Sackdoll from its Salt Lake City facility. Fabrication of the tank started in April and is scheduled for completion in October. Douglas Aircraft Company has shipped a full-scale mock-up of the forward dome and skirt section of the S-4B stage to Marshall this quarter. The mock-up will be used in connection with design of the Saturn IIB instrument unit, which will fly atop the S-4B stage. A 2-month contract was let to Aero Space Lines Incorporated by Marshall to study the feasibility of using a modified Boeing C-97 for air transport of the S-4 stage, 1.5 million-pound thrust rocket engines, and other massive components. This mode of transportation would greatly reduce time required to move the cargo from the West Coast to points in the south and east. The modified Stratocruiser, now known as the B-377PG Pregnant Guppy, has successfully transported an inert Saturn stage from Los Angeles to Edwards Air Force Base. The Guppy is now undergoing rigid testing to prove its takeoff, in-flight, and landing capabilities during Federal Aviation Agency qualification tests. These flights are expected to cut transportation time from 3 weeks, now required for barging cargo through the Panama Canal, to about 12 hours of flying time from coast to coast.